This video is to allow you to correct your homework from section 8.1.3, problems 839 through 843. So they want you to assume that the histograms below represent the amount of time it took two different groups of 100 people to run a 5K race. Assume that the mean of each histogram is the same. Which group has a greater mean absolute deviation and why? So what we know is that mean absolute deviation involves first finding the mean and then looking at how much the different individuals, or in this case, the different race times, differed from that mean. So what we're looking for is which one has more dramatic difference from the mean, from the average. And what we're going to see is that group A would have a greater mean absolute deviation, because if the mean is what we consider to be the center of the data, then we see that group B has more points near the center. So we see sort of this bell-shaped curve here, and these values are all, within fairly close to the center, to the middle, right? Where here they're sort of all up and down, and therefore not very close to what would be considered a typical value. All right, so group A would have a greater mean absolute deviation. Again, we obviously can't calculate it because we don't have any numbers, but based on what we see in terms of the shape of the curve, that would be our presumption. Then they want you to describe the shape of the distributions in that problem using the vocab list that they gave us previously. So what you should say is that group A would be double peaked and symmetric. Double peaked, remember, means you have one area where it's got a peak and then a second area where it has a peak. And symmetric because these two are almost, not quite, but almost mirror images of each other. So if we came through with this being the mirror in the middle, those two are both fairly close to mirror images of each other. Where this one, group B, has just a single peak, and this one though is also symmetric because again this would be like the mirror and both halves are pretty close to mirror images of each other, so we call that symmetric. For 841, Kayla had a 14-foot rope that she cut into 3 pieces. Now 2 pieces are the same length and the third piece is 2 feet long. So they want you to first copy this diagram onto your paper and then write an equation that represents the situation, and you need to define your variable. So this would be our unknown. We can see that from the question mark. We'll make that into our variable. Maybe we'll use x, maybe we'll use something other than x. But when we define our variable, that variable will represent that unknown length. So what we have for an equation is that this 14, which is the whole thing, has to equal x plus x, which would be 2x, plus 2 feet. So that's where this is coming from. And again, we're told that these two are the same length. That's why we use x for both of them. Then they want you to solve the equation and find the length of the 2 equal pieces. And we get 6 feet because 2 times 6 plus 2 would equal 14 feet. Here you have to complete a portions web. Remember, a portions web means we're going to have our fraction, decimal, percent, and words. So we have here a fraction. One way to change it would be to go ahead and use a giant 1 and change it to hundredths, because we know percent is out of 100. And we can also use hundredths to get the decimal. So this is times 5 in the denominator, so times 5 in the numerator. If we do that, we would get 15 out of 100 is 15%. It's also 15 hundredths as a decimal and 15 hundredths in words. Now, I want to point out a couple of things. Number one, you could also have used 3/20ths for words. The words can come from the fraction or the decimal. And the other thing I want to point out is that if this had not gone so nicely into 100, we could have found that decimal by taking 3 divided by 20, numerator divided by denominator, and we would get this 15 hundredths, which is 15%, which is 15 hundredths. Now, that may be why we want to approach this one, because 3/40ths, again, 40 will not go very nicely into 100. So you could take 3 and divide by 40 on a calculator or through long division. You get 75 thousandths. When you move your decimal 2 places to the right and add a percent sign, you get 7.5%. And of course, the word for that is 75 thousandths, or you could use 3/40. Here you have to solve and graph these. So we have x minus 9 is less than 17. We can add 9 to both sides because our goal is to get x by itself. So how do we get rid of a minus 9? We do a plus 9. And when we do that, we have to do it to both sides to keep the balanced equation. So the x will come down, the plus 9 and minus 9 zero out, and 17 plus 9 would give us 26. So this would be considered the part where they say solve the equation. So x is less than 26 is solving it. The x is coming down, the less than symbol is coming down, and 17 plus 9 is 26. Then as far as graphing it goes, that would be on a number line. So we'll make a basic number line, and we're going to put the value of 26, and we want to show that x has to be less than 26. So since x has to be less than 26, we're going to show values to the left, and we're going to have an open circle. And remember, the reason we're having an open circle is because x cannot be equal to 26, only less than 26. If we'd had a equal to sign right here, less than or equal to, then this circle would have been filled in and it would be solid because x could be equal to 26 or less than 26. But since we don't have that, this is our correct graph. Here we would start by subtracting 12, because again, how do we get rid of the plus 12? We subtract 12. That's the inverse operation. When we do that, the plus 12 and minus 12 zero out. So the x would come down. The plus 12 and minus 12 are zeroed out. The less than or equal to symbol comes down. And 6 minus 12 is negative 6. You can picture it on a number line. So we have x is less than or equal to negative 6 for our solving it. Again, for our graphing, that's going to be on a number line. So there's a number line. We have negative 6. Its values that are to the left of negative 6 because it's less than, and a closed circle at negative 6 because negative 6 is also included as part of the solution. And again, what tells us that is this symbol right here. That's what tells us to make that a solid circle. And for this one, what we typically do is like to rewrite it. We can rewrite it at the first step or a later step, and I'll show you what I mean for that in a moment. So we want to get x by itself. We can subtract 4 from both sides. Then when we do that, 10 minus 4 is 6. The greater than or equal to symbol comes down. 4 minus 4 zeros out, and the x comes down. But when we want to graph an inequality, which is what this is, we always want the x to be on the left. It just makes it easier. So we're going to take this x and we're going to put it here on the left. We're going to take this 6 and we're going to put it here on the right. The key is we need to make sure when we rewrite this that it still represents what we had up here, which is that the symbol, the arrow, so to speak, has to be facing the x. So the wide part needs to be facing the 6 and the arrow part needs to be facing the x. So x is less than or equal to 6 is equivalent to what we have here. And that makes it much easier for us to graph because, again, very much like what we had before then. So I always encourage you to have the variable on the left side when you graph it. And again, you could have even done that in the first step.